Okay, welcome to Chapter 13, our fourth lesson, the binomial theorem. This does have to do with our probability, but it also has a lot to do with a lot of other math type stuff, as you'll see. Okay, we're going to use the binomial theorem to calculate binomial coefficients. We're going to use Pascal's triangle to calculate binomial coefficients, and we're going to use binomial coefficients to write binomial expansions. Okay, this is a Pascal's triangle. You can write one up super easy, super fast. All they are is each term is the sum of the two terms above it. So, as you can see, the 10, here we go, okay. The 10 is comprised of the 6 and the 4. The 21 is 15 plus 6. So you start out, when you go to write one, you start out with a triangle of ones. Sorry, that's 1, 1, 1. Okay? Then you have 1. 1 and 1 is 2. And a 1. Then 1. 1 and 2 is 3. 2 and 1 is 3. 1. 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And then a 1. 1, 5, 4 and 6 is 10. 10. Notice there is symmetry. It's identical backwards and forwards. 1, 6, 15, 20, 15, 6, 1. Okay. These are important. You need to know these rules. Each row is defined by the second term. So, for example, this is the 6th row, 5th row, 4th row, 3rd row. But each term, remember, you have the ones on the ends. So even though this is the 6th row, there's 1, 2, 3, 4, 5, 6, 7 terms. Okay, so the 6 is actually the second term of the row. Okay. And remember, there is balance, there is symmetry here. All right, now, in writing out the 5th and 6th row, what we know is that 6C0 is 1. 6C1 is 6. 6C2 is 15. 6C3 is 20. 6C4 is... So you can figure these values out this way too. And 6C6 is 1. Okay, these are exactly the same. And again, you can see the symmetry. Okay, now the binomial expansion. Here it is. Okay, are you as confused as I was the first time I saw it? I bet you are. It is like, what the heck is this all talking about? Okay. It's not as hard as it first looks, but we're going to explore the patterns first, and then I'll show you how to actually do this. Okay, the binomial theorem provides useful method for raising any binomial to a non-negative integral power. So, x plus y to the 0, that's easy, it's 1. Anything to the 0 is 1. X plus y to the 1, x plus y 2, so squared. We know this form because we have done this before. X plus y to the 3, x plus y to the 4. Okay, so that's what this is all about, is expanding binomials. Now, there won't always be x plus y. You can have 2x plus 3, that kind of thing. So we're going to go and show you how this works. All right, now, what I've just presented is the formula for the binomial theorem. I find it to be complicated and confusing. What I'm about to present is the method I developed to make it easier for students to understand and use the patterns built into the binomial theorem. Okay, so let's look at this. What we do is we set ourselves up a table. It's going to take 4 rows. Your first term, okay, your first term is, sorry about that, go away. This is my first term. So we're going to put that value in each of these spots. Okay, now I want you to notice that the first term goes to the 4 whoops, let me give you a different color for that because it's going to be confusing otherwise. 4, so this is 4. And it counts down. On the second term, it counts up to 4. Okay, so my second term is the 3y, and it's going to go in each of these spots. And I'll write them out in a minute. Okay, then we have Pascal's number. And I will explain that as we get to it. Okay, so let's look at this. All right, 2x is my first term, so it's 2x to the 4th. Well, that is 4x. Oops, no, it isn't, not 4. Oops, wrong one. 2 to the 4 is 16. So this is 16x to the 4th. Then I have 2x cubed, which is 8x cubed. Okay, and now 2x squared is 4x squared. 2x to the 1 is just 2x. 2x to the 0 is 1. Okay, now we're going to put in our second terms. So it's 3y to the 0. Well, 3y to the 0 is 1. Now 3y to the 1. 3y squared. 3 squared is 9. Y squared. 3y to the 3. That's 27y cubed. 3y to the 4th is 81y to the 4th. All right, now we're going to look at our Pascal's triangle. So we need, which row do we need? We need our 4th. Fourth row. All right, so I'm going to write out the 4th row real quick. We have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There we go. All right, so 1, 4, 6, 4, 1. This is why the Pascal's triangle is handy. All right, now we multiply down the column. So I'm going to multiply 16x squared 1 times 1. So I get 16x to the 4th. Plus, now again, I'm going to multiply down 8x cubed, 3y, and 4. So 3 times 4 is 12, times 8 is 96. So I have not, sorry about that, wrong color. I have 96 x cubed y. Plus, now I have 4 x squared, 9y squared, and 6. So I just have to multiply those numbers together. 4 times 6 is 24. 24 times 9 is 240. Minus 24 is 216. Y squared. Nope, sorry. X squared y squared. Plus, now I have 2 times, so you can just type these into your calculator. 2 times 27 times, I hit a minus accidentally. 2 times 27 times 4. So I have 216 again. X, y cubed. And now I have 1 times 81, y to the 4th times 1. So it's plus 81 y to the 4th. And that is your answer, and you're done. Okay, it's not as awful as that other thing looked like. That is so confusing to try to explain. But this is something you can do. It's not that bad. Okay, so let's move on. All right, calculate the binomial coefficient 8C6. All right, another way to do this is to go and do 8 with the 6th term. The 8th row of the So you could do it in your calculator, probably the easiest, but I'm going to do it this way just because you're learning about Pascal's triangle. 4, 6, 4, 6. Nope, not 6, 1. Okay, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35. Then back down again, 35, 21, 7, 1. Now my 8th row, 1, 8. 7 and 21 is 28. 21 and 35 is 56. 35 and 35 is 70. And then 56, 28, 8, 1. So now I want the 6th term. So 0, 1, 2, 3, 4, 5, 6. That's the 6th term. So my answer is 28. That's one way to do it. Okay, I could also have used my other form. All right, you know how the formula I gave you last class, or the class before that. Anyway, use the binomial theorem to expand and simplify this expression. So we have first term. So I have a to the 4, a cubed, a squared, a, and 1. The other one I'm going to have 1, 6, 6 squared, 6 cubed, and 6 to the 4th. I don't know that one off the top of my head. 12, 9, 6. Okay. And then Pascal's list, which is the 4th row. So you can see I have it already up here. That's the 4th row. That gives me Pascal's numbers. 1, sorry, can't read it well. 1, 4, 6, 4, how come? 1, 4. There we go. I'm sorry, I was just not seeing the column. All right, so now I'm going to multiply this together for my final answer. A to the 4 plus 6 times 4 is 24 a cubed plus 36 times 6 is 216 a squared. 4 times 216, I could probably do it, but my head hurts. 864 plus 864a plus, whoops, I have no idea where that came from, plus 1296. So that would be my final answer. Okay, up here. So I would have had a 1, 1. I don't have my guard on. Okay, it looks like I'm still recording. A 1, a 9, and then 28 and 8 is 36. So now it says to use the binomial theorem to expand and simplify this expression. Now I have, of course, but it's a little trickier because I have x squareds. So my exponents are not just going to be 4, 3, 2, 1, 0. My exponents are going to be 2 to the 4, which is 8. 2 to the 3, which is 6. Okay? So I have x squared to the 4. That's x to the 8th. X squared to the 3 is 6. X squared to the 2 is 4 squared and 1. Now I have, whoops, that's supposed to be just a 1. Y squared, y to the, oops, nope, that was y squared, pardon. Okay. Y squared, y to the 4th, y to the 6th, y to the 8th. So now I need my Pascal's numbers, remember. So this is another 4. So it was 1, 4, 6, 4, 1. So my final answer is going to be x to the 8th plus 4x to the 6th y squared plus 6x to the 4th y to the 4th. Yeah, my 4s are looking a little weird. Plus 4x squared y to the 6th plus y to the 8th. And there we go. Multiplying down each column, and you got it. It's not too bad when you divide it up into the 3 rows. When I wrote a 9, okay. Now, this is a little trickier. We're being asked to find a specific term. Okay, but we're going to break this down and think about this. Okay, the nth term, the 8th term. Okay, so that means I'm going to have, remember, each row of the Pascal's triangle, and therefore in an expansion, has one more than the nth. So it's to the 9. So there's 10 rows, 10 terms. Okay, so the 8th term is almost to the far end, right? So my numbers are going to be, for the top row, I start at the 9 and count down. So I'm going to have 4x to the 7. We're counting, sorry, we're counting down. I apologize. Okay, sorry, this is a 4x, just doesn't look like it. And another 4x. That one's to the 0, 1, 2. Now, for the 3 y's, they're going to be to the 9, to the 8, to the 7. Right? Okay, and at the end of our 9th row, we would have had a 1 and a 9, and then this number. So let's go back and look at the, this would have been 36. So my answer is all of this multiplied together. So 4 squared is 16. So I'm going to have 16 times 3 to the 7. And then times the 9, times the 36. So the number is 1259712. But it wants the whole term, so now I have x squared y to the 7th. Just remember learning about the patterns built in. All right, now, in this next one, all they want is the coefficient. They just want the number. So we just have to figure out which number it would be. Now it's 9. I am caring about the extra stuff a little bit. But notice which term it is we're talking about. X to the 4, y to the 5th. So I would have had x to the, sorry about that. Okay, I would have had x to the 4, x to the, 9, 9, 8, 7, 6, 5, 4. So that's the term I want. For the y's, I would have had 0, 1, 2, 3, 4, and 5. So I know right off I'm going to have a 1 to the 4, right? Because there's a 1 right here, sorry. Okay, and then I have a -2. So I'm going to have a -2 to the 5. Then now all I need is that term. So I need the 1, 2, 3, 4, 5, 6. No, yeah, the 6th term over. So I can use my NCR thing to do that, right? So I have 9 altogether. 9C, and it's 0, 1, 2, 3, 4, and 5. 9C5. I can plug that in my calculator. And then I'm going to multiply all these together. So 1 to the 4 is just 1. You can ignore it. Minus 2 to the 5 is going to be a negative 32. So it's this number times a negative 32. So I'm going to go 9 math over to probability 3. I get 9C 5, step out of the subscript, times negative 32. And I get a negative 4032. All right, you just got to recognize the patterns, and you've got the term. So that's the number. There's a number of different ways to find these. Okay, a binomial experiment consists of n independent trials where each trial has 2 possible outcomes, success or failure. So there's a lot of these different probabilities that can be written this way. For example, probability of rolling a die and getting a 2. Well, the 2 is now a success, and the probability of a failure is a probability of getting anything but a 2. Okay, so that's now binomial. Bump, okay? All right, the probability of success is P, and therefore the probability of failure, Q, is 1 minus P. It's the complement of P, success or failure. There's not in between. All right, so binomial probability in a binomial experiment where the probability of success in each trial is P. The probability of X successes in N trials is. Well, basically, that's one of those terms that we did of the binomial expansion. Okay, but this formula is important for you to remember, so I want you to make sure that you write this down, put it in your on your formula sheet. Okay, so make sure you do that. I've put it up at the top of the slide for right now until we get used to it. All right, find the probability of getting exactly 4 heads on 7 flips of a fair coin. Okay, so the probability of 4 heads on 7 flips. All right, so the probability of getting a head is 1/2. That's where this comes in. The probability of getting not a head, well, we know that's a tail, is also 1/2. Okay, so it's going to be C, the 7. Okay, and then this is, where am I? There I am. Okay. Oops. This number right here, the 3, is really 7 minus 4. That's what that 3 is, okay? So how we come up with that value. All right, you found the 7, and there's a 7 here. Whoops. There's a 7. All right, then the probability of P is 1/2. The probability of not P happens to be 1/2. And N is 4. Nope, I still have red. I thought I was almost out of colors. Of getting 4 heads, that's this number right there, and there, and there. Okay, so that's how we get all these values. Now we can put this in our calculator and figure out what it is. Okay, so I'm going to go 7 math probability 3, so 7, 4. Step out of the subscript, parenthesis 1 divide 2, close parenthesis to the 4. Step out of the exponent, parenthesis 1 divide 2, close parenthesis, to the 3. Excuse me. Okay. So my probability, sorry, my silly thing keeps, my hand keeps making me self the problem here. Okay, so my probability, I put it all into my calculator. I get 0.2734. That's my probability. Okay. Or you could say 27%. All right, a probability distribution is a function that assigns a probability for each possible outcome. The sum of the probabilities must be equal to 1, and this can be summarized in a table or graph. So here we are, okay? It's just a list of all the probabilities of something happening, and it's only going to always equal 1. So if I added up all these numbers, I'm sorry, I must be having an allergic reaction to something because I'm suddenly plugging up. Okay, the sum of all these numbers is 1. You notice this does not go to 1 because the sum of each bar is going to equal 1. All right. So here we have a student randomly guesses on each question of a quiz consisting of 5 multiple choice questions, each having 4 choices with only 1 correct answer. All right, create a probability distribution modeling the probabilities of each number of successful guesses. Okay. So what is our equation? Whoops. I keep doing that. NCR P to the R, P to the R, Q to the N minus R. That's what our equation is. Each one of these terms. So the probability P, a student randomly guesses on each question of a quiz consisting of 5 multiple choice questions. So the probability of getting the right is 1 in 5 because there's only 1 right answer. So these are all 1/5. Okay. The second term is 1 minus 1/5. So that's going to be, okay, that's going to be 4/5. Okay, so I'm sorry, I'm just having a hard time reaching the bottom of my screen. 4/5. Okay, but we know that 4/5 to the 0 is 1. Okay, and 4/5 to the 1, which is just 4/5. 4/5 squared, we know, is 16/25. 4/5 to the 3 is, 4 to the 3 is 48, no. 64, sorry. 64 over 125. And then 4/5 to the 4 is going to be, I need to get my calculator. By the way, I apologize to those of you who tried to watch this without video or audio. I mean, the first time round. But, you know, sometimes I accidentally hit the little mute button and then you can't hear me. Okay. All right. 4 to the 4th is 256. And I believe 5 to the 4th is 625. Yep. 256 and 625. Interesting. Whoops. My hand's hitting the screen. 256 over 625. All right. And now to the 5th. 4 to the... What the heck? Okay, 256 times 4 is 1024. Oops. Not 1025. 1024 over 5 to the 5th. is 3125. Wow, okay. So, create a product, that's what we're doing. All right. I've got Pascal's number here. So now we just multiply down the columns. 5 to the 1/5, 1/5 to the 5 is 1 over, 3125. All right. 5 to the 4th, this is 1 over 625. This one is 1 over 125. And 1 over 25. And 1 over 5. And 1. Okay. So, multiply down. I'm going to get 4 over 325 times 5. So 4 over 625. All right, here, let's see. 10 times 25, 125 times 25. But I lose one of the 5s. So 625 again. 16 and 2 is 32. So I get 32 over 625. For the 10th one, now, this is much easier to just put in your calculator. With all these fractions, it's very annoying. And you'll get decimal answers, but that's okay. But you can put it in your calculator, right? Does everybody remember how? I'll go over it real quick. You're going to put the formula NCR, P to the R, Q to the N minus R. So we have N is 6. R is going to be our X value. NCR, P is 1/5, and Q is 4/5. So what you're going to type in your calculator is going to be 6CX parenthesis 1/5 close parenthesis to the X parenthesis. You have to step out of the exponent. Parenthesis 4/5 close parenthesis to the 6 minus X. Put that in your calculator. You go to the table and it's going to give you all these values. All right, done. So it makes it much easier to go through and do all these values. Here, I'll do it real quick. And then the last half of the values I'll put in decimal form. So, get your calculator, go along with me. 5, math, arrow to probability, 3, X. This is the XT theta N button. Parenthesis, 1 divide 5. Parenthesis, to the, that's that little caret symbol above the divide, X, step out of the exponent, parenthesis, 4 divide 5, close parenthesis, to the, again, the small caret above the divide sign, 5 minus X. Is it 5 or is it 6? 5 multiple choice questions, so yes, it's 5. All right, and then we go second, once we got it all typed in, table, and sure enough, there's all my values. So, the third value is 0.0512, 0.0064, and 0.12332. Those are the decimal values, and that is a fine way to do this. Okay. So, distribution. This is a probability distribution. It has the highest value. 1 was 0.4096. So it's only almost a 50% chance. Okay, so you realize it wasn't 6, it was to the 5, is what you should have been putting in. 5 minus x and 5cx. Yeah. Okay. Alrighty. The most likely outcome is getting one question correct. We know that because of getting, here's some of the numbers listed out. 3276. I don't see how that's adding the values. That one's not correct. I apologize, because that's not adding 0, 1, 2, and 3. That's adding all 6. All right. Yep, that's the right equation. All right. And then we're done. Okay, that wasn't too bad. I'll get this up right away.